In this video, we'll be talking about the torch probe button that is available on the main screen of OptimumCNC plasma cutting software, and the ways in which it helps the operator locate the surface of the material that they're working with. We'll touch upon the floating head sensor and the Ohmic sensor, as well as some of the options within our plasma settings, namely our ignition height and our switch correction, also called the IHC correction height. So how does the torch probe work? Essentially, the torch probe utilizes two sensors that are connected to our torch. This is our Ohmic sensor that we can toggle on and off, as well as our floating head sensor. The way in which these sensors work is a little bit different, however, they perform largely the same function, essentially to locate the point of contact between the torch and the working surface. Let's start with the Ohmic sensor, as it is usually the simpler of the two to grasp. Essentially, the Ohmic sensor is directly connected to the torch, so once the torch moves down, the Ohmic sensor will be engaged as soon as the torch touches the work surface. That means that there's zero correction between the Ohmic sensor and the torch itself. The floating head sensor is the second sensor that's available on OptimumCNC Plasma, and there is some kind of a correction or some kind of play, meaning that once the torch goes down, it will touch the working surface, and then it will take just a little bit more downward motion to engage the floating head. So why is the floating head used? Well, let's say that the Ohmic sensor doesn't recognize that we have touched the work surface. Perhaps there's some liquid on it, perhaps the material is dirty, so we're relying on a more mechanical system with this kind of a button press almost. This means that there is some kind of a correction value. It's usually quite a small value, and it's something that we set just once per the machine. However, it's something to keep in mind. And this correction value is set right here within our IHC correction height, also called the switch correction, or value B within our plasma settings. So again, the system will essentially move down. It will see that either our Ohmic sensor or the floating head sensor have been engaged, at which point this tells the system that this point, this machine coordinate that they're currently at, is the work coordinate of 0. So right now, there's no difference between our work offset, our program coordinate, and our machine coordinate in red and blue, respectively. So let's say we move downward, the two are the same. However, once the contact has been made, the system recognizes that whatever point the sensors have been engaged at, that's the work 0, and it will set this coordinate to 0. Next, the system will move up a little bit, and the reason it does move up is to move it to the ignition height. So right now the height for the value A, ignition height, is set to be 0.06. However, we can set it to any kind of a value, let's say 0.1 perhaps, to demonstrate this. Now let's actually run the procedure, and for the first run I'm going to only use the Ohmic sensor. So right now I can toggle the sensors on and off, and for the first run we'll utilize the Ohmic sensor. So here, let's say we raise the torch up a little bit, we start moving downward. The system will see that the torch has touched the table because the Ohmic sensor is on, and it will raise the torch up a little bit after zeroing the coordinate, and it will raise it up by this value that's specified in the IHC, or initial height controlled ignition height. Now let's say that we would like to utilize the floating head sensor. The procedure then will be a little different because the torch will move downwards. At some point the floating head sensor will be engaged, the downward motion will stop, but then the torch will start moving upwards. And the zeroing, meaning that our work offset or work coordinate is set to 0, will happen at the exact point when the floating head sensor is no longer engaged. And the system will add this correction value. So let's say that for now, let's just set the ignition height to 0. This isn't realistic, but that will make the demonstration a little easier, so we see the values a little clearer. Let's say that we raise the torch up, let's say roughly to 0. Now we're going to run the procedure again, and this time we're going to utilize the floating head sensor. Now we're moving down. At some point I will engage the floating head sensor and the torch will begin moving up. Now I release the floating head sensor. The system will not raise the torch higher because, again, we've set the IHC ignition height to 0. However, it has added this little correction value. Let's run it one more time, and this time we're going to use some value that's a little bit more dramatic, just so we see it a little easier. Let's say it's going to be ½ an inch. Again, this is not at all realistic. This value, this correction value, is usually much smaller. However, we're going to simply use it so it's easier to see in our machine coordinates. Let's run the process again. We move downwards. Let's say at -3, we start raising up. At roughly -2, we have released the floating head sensor, and the system has set this work coordinate to 0 and added ½ an inch of correction to our machine coordinate value. Now let's set the values back to something that's slightly more realistic. And from now on, we can utilize the torch probe to locate the work coordinate or the program coordinate of 0 on our working surface of the metal. Thank you for watching.